So now this is from an example in the end of the section problems. So now it says to estimate g of 7. So since this is curved, we don't have a formula for this like a triangle or a square, but I'm going to estimate it's about 2, because this, notice the scale here, this is width of 1, a height of 2, and we can estimate that this is kind of, this area that's not included is about equal to, maybe it's a little bit less, but it's approximately equal to this area above here. So we estimate that the total area, we add 2 to what we had before, and it's 6. Okay, so what we were seeing was that g's telling us the area under this curve. We were seeing the area under this curve. But now let's look at the actual output values from g. So here, look at this table. These are the accumulated areas, right? These are just the y values, though, also output by g. So let's graph these points. So we've graphed these green points here. Those are the points from g. So notice a few things. Where does g have a maximum value, a local maximum? Notice f is 0 at this local max. Notice f is 0 at this local min of g. And notice again that f is 0 at this max. So that's making us think maybe f might be the derivative of g. Notice where g's increasing, f's positive. Notice where g's decreasing, f's negative. Again, there's more evidence that f just might be the derivative of g, which would mean that g is an antiderivative of f. So now if we connect those points and graph g, we see all the same things we saw before. Now I'm adding the slopes of tangent lines to g. So like notice this horizontal tangent line. So it has a slope of 0, and notice what f is. Here this tangent line has a negative slope. Again, a horizontal tangent line, slope of 0. So this is all adding up to tell us that, we're pretty sure that f's a derivative of g, or that, in other words, g prime equals f. So we need to prove that. So we're not going to go into a rigorous proof. That's in the book of this part, but g prime of x, what we've seen, remember we're going to look at what g prime of x might be. So remember the definition of the derivative as a limit of the difference quotient. So g of x plus h minus g of x is just the area under the graph of f from x plus h, or delta x, to x. So like we saw when we looked at that example back here, if you go from one x value to the next, the difference in the function is just the difference in the area here. So if we go back over to this slide, so g of x plus h, or x plus delta x, minus g of x is just that difference in the area under the curve. So it's like so when that delta x is small, it's like the area under the curve of a small strip, which has width delta x and height approximately equal to f of x. So this is telling me that the difference in area from x plus delta x to x is approximately the width delta x times the height f of x. So I can divide both of these by delta x, and look, I get f of x is approximately equal to the difference quotient. And then if we take the limit as h, or delta x, goes to 0, we get that derivative of g is equal to f. So this isn't the rigorous proof, but this, I think, gives a good picture of what's going on. So now here's the real theorem. If f is continuous on a closed interval, then the function defined by this integral, the area function, this function of x, is continuous and differentiable, and this is an antiderivative of f. So g prime equals f is telling us that it's an antiderivative on that interval. So this is another way to write that it's a little bit more obvious to see that the derivative of this guy g prime is going to be equal to the integrand evaluated at x, or just f of x. So let's look at another example. Find the derivative of this function. Well, this is just the area function for the function t minus t squared quantity to the 8th power from 5 to s. So we ignored the lower limit in going to give us the area underneath the graph of f of t, which is defined here. So, but if I take the derivative of g, what the fundamental theorem of calculus just told me was the derivative of g is equal to f evaluated at the variable. So g prime of s is just this function evaluated at s. So in practice, these problems are really easy. There was kind of a lot of buildup that seemed complicated, but when you just do the problems, this is pretty straightforward.